All right, so here we are in our next foray into Excel. This will be 12-1, number 21. And you can see here, a researcher wanted to determine whether pedestrian deaths were uniformly distributed over the days of the week. She randomly selects 300 pedestrian deaths recorded the day of the week on which the death occurred and obtained the following results. The data are obtained from the information obtained from the Insurance Institute for Highway Safety. Okay. And then we're going to test the belief that the day of the week on which a fatality happens involving a pedestrian occurs with equal frequency at the 0.05 level. So let's start here. You know what? Hold on one second. There, I just copied and pasted in a little bit. So the null hypothesis is that the proportions for each day of the week is equal. Proportions are equal. All right, and then they would all be equal. Well, if they were all equal, there's 7 days in the week, so it'd be equal to 1/7. So I think its proportions are equal. There we go. The alternative to that is that at least one of the proportions, so here it is, the proportions of fatality or pedestrian fatalities for each day of the week are not equal. At least one of the proportions is different. Okay? All right, and so the other thing to keep in mind here is I should have probably labeled what proportions I was talking about. So proportion of pedestrian fatalities. Awesome. Okay, so now I've got my observed in here. This is what came from the table that they gave us. Now what's the expected? Now in the last problem, they had given us a percentage, and so we had to just multiply each percentage times the total. Here they didn't give you a percentage, but you kind of know what it has to be. It has to be 1/7, because if every day of the week is equally likely, then that's 1 out of 7. And you'd multiply it by how much? Well, she said in the problem that she went and looked at 300. Right? It says look at 300. But the other way to find it is to find this total here. So let me go to this trouble here. So if I find equals the sum of this, it should be 300, right? It is. So what you can do is you can say equals 1/7 times that number, but that number can never change, so give it F4. So give it $sign. So there's a $sign in front of the B and a $sign in front of the 9. And then you can just click. Right? Now you think, oh, it's wrong. No, it's right. They're all equally likely. So every day should have about 42.87 or 857 deaths. Kind of depressing, I know, but true. All right, I'm going to drag this over here, and I want it to be the sum of these columns. See? It's adding up to 300. Good. All right, so now we're going to need to find the test statistic. We're going to need that observed minus expected. Hold on, I have it over here. Observed minus expected divided by expected. Oops, squared divided by expected. So let me take that. Parentheses, I observed 39 minus I expected 42, close parentheses, square it, divide it by that expected, and then you double click and put them all down. Okay, so remember, just on the side note, that every one of these expected values has to be greater than 1, and you can't have more than 20% of them less than 5, but we don't. They're all 42s. That's not talking about this column. This column's different, right? And this column lets you see, hey, look, Saturday is the biggest, contributor. Saturday's got the biggest problems. You can tell because it has the largest number in that third column. But our test statistic is going to be equal to the sum of that column that we made. I know you could do it all in one step without bothering with the column, but I like to see the column because it lets me see where the biggest problems are. For example, Saturday in this particular example. All right, so our test statistic is equal to 13.227. There we go. All right, now step 4, we won't have time to finish, but we can get it started. Step 4, we're going to want to do both the classical and the p-value method for our own edification. All right, so the classical, we're going to need to test or make a critical value. And I will show you how to find that at the beginning of the next video.